Hey, welcome back, everybody. So we just got done talking about a good way of predicting things in statistics. One of the ways you could do that is with confidence intervals. The second thing that I want to teach you that is similarly related to the math that goes behind confidence intervals is this thing called hypothesis testing. Hypothesis testing is pretty much the coolest thing I think in statistics. What it is it allows you to take a claim. Let me give you a couple examples of claims. For instance, a researcher claims that high school students sleep on average 6.5 hours per night, or a diet program claims to help people lose on average more than 20 pounds in a month after following the program. Or one you might hear on like an investors thing, but a commercial selling gold states that people investing in gold get on average a return of at least 20% on their investment. All of these claims sound great, but are they actually true? And one of the cool things about stats is there is a way to take a claim and prove mathematically if this claim holds water or if it's true or not. And you can do that based on kind of like your own kind of research. So what I'm going to do is I'm going to start by teaching you guys the initial steps to how a hypothesis test works. And we're going to pretty much start with the first two steps on each of these claims. The next lesson after this will be pretty much the math behind it. So I'll get you through like the first kind of stepping stones of the problems, and then I'll get you a little bit of practice on that. And then when we come back next time, I'll show you again a little bit more of the math or the remaining steps for these problems. So we'll kind of do it in two parts, okay? So let's begin with the first step. So the first step is to take the written word of the problem or the claim and turn it into symbols, okay? So this person is talking about an average, and the person is claiming that the average amount of sleep is 6.5 hours per night. Now, the first step I want to do is turn this into a symbol, okay? Or turn this into symbols. Now, when I'm dealing with an average, the symbol that we use for averages, specifically when we're talking about all high school students, is the population parameter, or this symbol, mu, which is the population average symbol. So that's the average symbol that we're going to use when we do a hypothesis test. So the average is 6.5. And it's not saying that it's more than or less than 6.5. It's saying that it is 6.5. So I'm going to write this as the average is equal to 6.5. Okay? And that is pretty much a symbolic form of whatever that researcher's claim is. Okay? And I'm going to do that for each of these claims. So let's go on to the next slide. So a diet program claims to help people lose on average more than 20 pounds. So similarly, I'm going to start with this symbol, the average, and the claim is that the average is going to be more than 20 pounds. So the symbol that I'll use for more than is, well, greater than, and I'll put a 20 after it. So that would be that claim for that problem, but in symbol form. And then last but not least, this last claim is talking about a commercial selling gold states that people investing in gold return at least 20%. Well, we're dealing with percentages here. And for a percent, the symbol that we're going to use for percent is the one that we were using for hypothesis testing, is just going to be a p, okay? So the percent is at least 20%. So I'm going to obviously have my 20% here. Now, the at least part, this is a little tricky. At least means, now a lot of people might think that that means less than. But it doesn't. If I give you, for instance, at least $20, the lowest amount I can give you is 20, and then anything above that. So really what at least means, it's a fancy way of saying greater than or equal to. So this would be that claim in symbol form. The counterpart to at least would be at most, but that would just be the opposite. That would be less than or equal to, okay? So the first step in these problems is to start by taking the claim and writing it in symbol form, okay? After you've written it in symbol form, the next step is to put your symbol form claim into what is known as one of two hypotheses, okay? In these problems, there are two hypotheses. The first of those hypotheses would be what is known as the null hypothesis, And then the second of these is what is known as the alternative hypothesis. And the reason why they call it a null hypothesis is because we're going to use H, what is known as sub-zero. This is actually a zero. Another way of saying zero would be null. So again, this is not HO. This is the null hypothesis. And then this is what is known as the alternative hypothesis, okay? The difference between these two hypotheses is basically based on symbols, or what symbols are allowed in each of these hypotheses. In the null hypothesis, you are only allowed equality statements. So for instance, equals, greater than or equal to, or less than or equal to are symbols that are allowed in the null hypothesis. And then the alternative hypothesis, inequality statements are allowed in there. So for instance, not equal to, less than, greater than, okay? So if you take a look at this claim in symbol form, you'll notice that the symbol we use is equal. So our claim, what we're going to do is we're going to put it in one of two spots, either the null or the alternative hypothesis. So what I'm going to do is I'm going to stick that claim into that slot. So mean is equal to 6.5 for that for this problem. And I'm going to put a little C next to it to designate that that is the claim for the problem. And the second part to this, once you've put your claim in the appropriate hypothesis, is to write the opposite hypothesis. So logically speaking, either your claim is true or your claim is the opposite of that. So the opposite of being equal to 6.5 would be, you guessed it, not equal to 6.5. So my alternative for this one is going to be the mean is not equal to 6.5, okay? So again, you place the claim into one of two hypothesis slots, and then you write the opposite claim depending on wherever the claim shows up, and you do that by, again, thinking of opposites. So the opposite of equal is not equal to, the opposite of less than is greater than or equal to, and then likewise, the opposite of less than or equal to is greater than, okay? So that would be the second step of this problem. So let me show you the second example real quick. We'll do this a little bit quicker now. So again, the claim for this diet program was what? Mean is greater than 20, right? So if I'm going to place this into a hypothesis, I'm going to write the null hypothesis, the alternative hypothesis. I look at this symbol and I think, what symbol is this? Well, this is greater than. So which of these two will I put it into? Well, because this doesn't have an equal sign, I'm going to put this claim actually into the alternative. Put a little C there to designate the claim. And then I'm going to write the opposite hypothesis. Well, the opposite to greater than would be less than or equal to. So that would be how I start this problem, okay? So the null for this problem is less than or equal to 20, and then the alternative is the mean is greater than 20, okay? So let's try that last one real quick. So for this one, it's a percentage problem, same idea. So I'm gonna start with null, alternative, take a look at my claim. It's greater than or equal to 20%. This has an equal sign, so I'm going to put this claim in the null, so greater than or equal to 20%, and that is my claim. And then the alternative to greater than or equal to, or the opposite of greater than or equal to, would be less than, so that is what I'm going to write for my alternative hypothesis, okay? So the big takeaway for the second step, when you place the claim, just take a look at the symbol that you're using, and if it has an equal sign at all, so equals to, greater than or equal to, or less than or equal to, that claim will go into the null hypothesis. If your claim doesn't have an equal sign, then the claim goes into the alternative. After you place your claim into one of the two hypotheses, you just write the opposite claim in whatever spot needs filling, right? So in this case, we filled in the alternative because we had already filled in the null, okay? Okay, and now the third step. So once you've written the claim as a symbol, put it into and set up the null and the alternative hypothesis, the third step, and this really isn't that hard of a step, is to draw what is known in statistics as a tail test. Now the tail test, the way you draw these, it's pretty easy to draw. You draw a bell curve, And then you are going to draw one of three scenarios, and I'll explain kind of how these scenarios are worded, what to do for each of these scenarios. But it's either going to be what is known as a left tail test, a right tail test, or a two tail test. Okay. And the way you figure out which tail test you are going to be doing, or which tail test you are setting up, is based on the alternative hypothesis. Okay, so at this third step, what I want you to do is take a look at the alternative hypothesis and look at what symbol you see. Now, if you see a not equal to sign, then you are doing what is known as a two-tail test. If you see a less than sign, you are doing what is known as a left tail test. And if you see a greater than sign, you are doing what is known as a right tail test. A two tail test looks like this, where you're going to draw a boundary, and then you're going to shade everything left of that. And then you draw a second boundary, and you're going to shade everything right of that. Okay. Now, when we come back next time, there's going to be numbers that you're going to place here, and that's going to be kind of significant for proving or disproving a claim. But we'll talk about the second time around. At this point, I want you to just be able to set up the tail test. Okay. So again, our alternative tells us which tail test to do. That's the job of the alternative hypothesis, and that, again, symbol means two tail test, left tail test, right tail test. Okay, let's go to the second one. So the second one, again, is our diet program. We have, again, our claim is the alternative this time because of just the way the symbols worked out. What I'm going to do here is I am going to set up, based on this alternative, in this case, because I'm looking at my alternative, I see a greater than sign, so this is going to be a right tail test. This is going to look something like this. So again, bell curve, but this time I'm only going to do a boundary part on the right-hand side and then shade to the right. That would be a right tail test, okay? And then last but not least, this would be the last of those options. So here's our third example. So we set up our hypothesis. Our alternative hypothesis for this scenario is a less than. So in this case, I am going to go ahead and do what is known as a left tail test. Okay, this would be the third of those scenarios. So I'm going to draw my bell curve. I'm going to do a boundary point on the left side this time, and then I'm going to shade everything in the bell curve to the left of that, and that would be a left tail test. Okay. Again, there's more to these problems than just that, but this is the beginning steps and arguably actually the most important parts of these problems. Okay. So in conclusion, what you're going to do is you're going to start by writing the claim in symbol form when you start these problems. 2, put the claim into its appropriate hypothesis. And again, the way we determine that is the symbols that are allowed in the null are equal to, greater than or equal to, or less than or equal to. The symbols that are allowed into our alternative hypothesis are not equal to, less than, greater than. And then obviously after you place your claim, you write the opposite claim. You fill in whatever hypothesis you still need to fill in with its opposite hypothesis. And then third, and like the last thing that we went over, is the tail test, okay? And that is again coming from the alternative hypothesis, okay? So you look at your alternative hypothesis, doesn't matter if it's the claim or not, and if you see a not equal to sign, you are doing what is known as a two-tail test. So you draw your bell curve, you draw boundaries on left and right, and that would be your not equal to. What would happen if it's in the alternative? A left tail test if it's less than, so your bell curve and then everything to the left. And then similarly, if it was a greater than, you draw your bell curve and then boundary point to the right, okay? If you can do those 3 steps for these problems, you're off to a great start, and the next part won't be as bad for you, okay? And we'll go over the next part next time, okay? So the assignment today is going to just be setting up through step 3. So writing the hypothesis out into its appropriate hypothesis, then setting up the tail test, and then stopping there. I'll tell you where to go from there next time, okay? You guys have a great day. See ya.